Hi all, welcome to Anil Nair Classes YouTube channel. Today in this video, I am going to discuss one of the most complicated, most ignored topic by the student community as well as the teachers community on application of logarithms. Logarithms is an extremely important concept. By using logarithms, you can find the number of digits. You can find the number of digits for a power function, number of digits in a power b. Number of digits in a power b can be done beautifully by applying logarithms. You will be at the end of the class, you will be able to find the number of digits of 5 power 43, 15 power 72, 10 power 203. Complicated questions, very easily it can be done by using logarithmic concept. But before we discuss that one, some important key points we will revisit. Some important key points. As you know, exponential function and a logarithmic function both are inverse functions of each other. A power x is n, x equivalent to log n base a not equivalent to 1, a not equivalent to 1. For example, if 3 power 4 is equivalent to 81, 4 can be written as log 81 base 3, log 81 base 3. This is an exponential function, this is a logarithmic function. Both are inverse functions to each other. Second important property, log a base a, it is nothing but 1. Third important property, if there is a power 2 in place of n, a power b base c, b can go to the front. This will become b into log a base c. These three examples I am going to use it. These three important properties of logarithms I am going to use it to find the concept of how many number of digits will be there in the power function a not equivalent to 1. Now listen carefully. Two important key points are there. If you understand the two important key points, you will be able to solve a problems very easily. I will try to make it as easy as possible. Log 10 base 10, log 10 base 10, it is nothing but 1, because 10 power 1, it is nothing but 10 in an exponential function. Log 100 base 10, this is nothing but 2. Why? Because 10 square is 100. If I convert into logarithm, this will become log n base a. Now if you see, this is n is 10, here n is 100. Take any value which is between 10 and 100. For example, if I take log 80 base 10. Now if you observe here, 10 power 1 is 10. 10 square is 100. 80 lies between 10 and 100. That means this value lies between 1 to 2. This value lies between 1 to 2. Any value which is greater than 1 and less than 2 is nothing but in the form of 1 point something. It could be 1.2, it could be 1.6, 1.9 and anything. So there is a representation of a numerical value before dot or after dot. Numerical value before dot is called as characteristic. Any value after dot is called as mantissa. It is called mantissa. Value before dot and value after dot. Similarly, one more example, log 1000 base 10. 10 cube it is 1000. Let me take a value from 100 to 1000. Suppose if I take a value log 750 base 10. 10 square it is 100. 10 cube it is 1000. So the value 10 square equivalent to 100 and 10 cube equivalent to 1000. So this value lies between 2 to 3. This value lies between 2 to 3. Any value greater than 2 and less than 3, it is written as 2 point something. So 2 is the characteristic and any value after dot is nothing but the mantissa. Any value after dot is nothing but the mantissa. I hope it is clear. Now one important point, here characteristic is 1. How many digits are there for the given number? 2. Here characteristic is 2. How many digits are there for this number? 3. If the characteristic is 3, number of digits will be 4. If the characteristic is x, number of digits will be x plus 1. Please make a note of this point. I hope the idea it is clear. Just give me 1 minute, sir. One technical issue. Please make a note in your notebook. Make a note in your notebook. Now, let us write down the point. So, what is that we got? We got it as, if the characteristic is x, if the characteristic, if it is x, number of, let me take it as alpha, why to confuse with a power x equivalent to n. If the characteristic is alpha, number of digits will be alpha plus 1. This is for a given number n. Please make a note. If the characteristic is alpha, number of digits will be alpha plus 1. Now, how do you get these characteristic? For example, if the question is, find the number of digits for 2 power 20. Find the number of digits for 2 power 20. Some important values will be given in the question. All the problems, number of digits, we are doing it in decimal system. Log 2 value is 0.3010. Log 3 value is 0.4771. Log 5 base 10. Log 5, it is nothing but 5 can be written as 10 by 2 base 10. So, these is nothing but log 10 base 10 minus log 2 base 10. Log a base a, it is 1. So, it is 1 minus 0.3010. These is nothing but 0.6990. These are the three important values which will be given in most of the questions. Log 2, log 3 and log 5. 2 power 20, we need to find out the number of digits of this number. 2 power 20. Listen carefully, sir. Let me call it as x equivalent to 2 power 20. X equivalent to 2 power 20. Apply logarithm on both the sides. These is nothing but log 2 power 20. It is nothing but 20 will go front. 20 into log 2. Log 2 value, we know it as 0.3010. 0.3010. So, these is nothing but 10 will go to the front, 2 into 0.3010. I hope it is clear, right? So, these is nothing but, or probably we will do first problem like this, so that non-max students also will understand. 3010 by 4 zeros. So, 2 zeros will get cancelled. 301 by 100 is 2 into 3.01, which is 6.02. Anything before dot is nothing but characteristic. We got the characteristic. Number of digits will be characteristic plus 1. So, answer is nothing but 7. Answer is nothing but 7. I hope the idea it will be clear. So, why it is 7? Log x base 10, it is 6.02. So, x will become 10 power 6.02. This will become 10 power 6.02. So, 10 power 6 into 10 power 0.02. 10 power 0.02. This value, 10 power 1 will have 2 digits, 10 power 2 will have 3 digits, 10 power 6 will have 7 digits. The leftmost value will get multiplied with this numerical value. These all complicated calculations, we don't require it. We have seen the definition of characteristic. We have seen the definition of mantissa. How to find out the number of digits for a given number? It is given by characteristic plus 1. What is characteristic? A numerical value before dot after applying the logarithm. I hope the idea it is clear, right? That means in simple language, you can look at it. Number of digits in a power b. If I want the number of digits in a power b, the first important key point is, it is nothing but characteristic plus 1. It is nothing but characteristic plus 1. Then comes, how do you get the characteristic? Let me call a power b as b. This is nothing but log p equivalent to b log a. B log a. I hope it is clear. So, whatever the integral part that you get, this is nothing but the Find out the integral part of b log a. Integral part is anything before to the left hand side of dot. Add 1 to it. Add 1 to it. Why we are adding 1? We have seen the proof. I hope the concept is clear. Now let us discuss some problems. Find the number of digits. Easy onwards we will go. Find the number of digits for. Easy problems onwards we will discuss. First one, 10 power 36. 10 power 36. You don't need to do it. 10 power 1, it is 10. So 10 power 2, it is 100, 3 digits. 10 power 3, it is 1 followed by 3 zeros, 4 digits. Power 1 is there, I got 2 digits. Power 1 is there, 2 digits. Power 2 is there, 3 digits. Power 3 is there, 4 digits. 10 power 36. 36 zeros will be present. Leftmost one will be there. Answer is nothing but 37 digits. Answer is nothing but 37 digits. For 10 it is quite easy because it is in decimal system base. Log 10 base 10 it will be 1. Even if you look at it from a logarithmic point of view, that also will give you the same answer. This is nothing but x equivalent to 10 power 36. Log x equivalent to log 10 power 36 base 10. So these is nothing but 36 point something. These characteristic plus 1. 36 plus 1, it is nothing but 37. I hope the idea it is clear. 10 power 36. Answer is 10 power 37. Second one, 100 power 100. Third question, 100 power 1000. Fourth question, 2 power 12 into 5 power 15. Let us do one by one. So these are nothing but 100 power 1. It is nothing but 100. Total 3 digits are there. 100 power 2. It is nothing but 100 into 100. 4 zeros will be present. 4 zeros. So total 5 digits are there. 5 digits are there. I hope it is clear. Here there are 2 zeros. 2 into 1 plus 1. 2 into 2 plus 1. So 100 power 100. 2 zeros are there. 2 into 2 plus 1. 2 into 1 plus 1. So total it is 2 into 100 plus 1. Answer for the first question is 201 digits are there for 100 power 100. I hope the idea it is clear. Number of zeros are 2. 2 into 1 plus 1. 2 into 2 plus 1. 2 into 100 plus 1. Next one, 100 power 1000. Similarly, or we will change the question, 1000 power 100 let us do. Otherwise it will become similar. 1000 power 1, it is nothing but 4 digits are there. 1000 power 2, it is nothing but 3 2s are 6 digits are there. Now 6 digits are there. Similarly, 3 into 1, 3, 3 plus 1, 3 into 2, 6 plus 1, 3 into 100 plus 1. Totally how many digits are there? 301 digits are there. I hope you are understanding. Number of zeros into power plus 1. Number of zeros into power plus 1. So 2 power 12 into 5 power 15. It is 2 power 12 into 5 power 12 into 5 power 3. These are nothing but 125 into 10 power 12. I hope the idea it is clear. So these are nothing but 125. 10 power 1 will have 1 0 at the end. 10 power 2 will have 2 zeros at the end. 10 power 12 will have 12 zeros at the end. 12 zeros plus 3 non-zero digits. How many digits are there in the answer? 15 digits are there in the answer. 15 digits are there in the answer. Now first 4 problems are quite easy problems. Next one, 2 power 20, 3 power 41, 5 power 73. Find the number of digits in 2 power 20, 3 power 41 and 5 power 73. So these are nothing but x equivalent to 2 power 20. Log x equivalent to 20 log 2. 20 log 2. So these are nothing but 20 into 0.3010. So these are nothing but 2 into 3.010, 6.020, characteristic plus 1. So these are nothing but 7. I hope the idea it is clear. Probably if you are good in mathematics, you can also solve it as 2 power 10 whole square. 2 power 10 is greater than 10 cube. 1024 it is greater than 10 cube. So 10 power 3 power 2. 10 power 3 power 2 just greater than. So obviously it will have 7 digits. Idea it is clear? Right? 10 power 6 to 10 power 7. It will have 7 digits. Next one. X equivalent to 3 power 41. X equivalent to 3 power 41. Log x equivalent to 41 log 3. 41 log 3. Log x equivalent to. You should know the value of log 3, which is 0.4771. So log x is nothing but, if you observe closely, 41 4s are 164, 16.4 something, 16.4, or otherwise you multiply it, 4771 into 41, 41 ones are 41, 41 sevens are 287, plus 4 291, 41 sevens are 287, plus 29 308, 30, 41 fours are 164, 194, okay, 194, here 19.4. These were calculation little. 0.1 into 0.5, it will become 205. So obviously it cannot be 16.4. So multiply the entire number. 19 plus 1. It is nothing but 20 digits are there. Calculation little be careful. If you do 0.5 into 41, 0.5 into 41. So 0.5 will be 1 by 2. This will be 20.5. 0.4771 is closer to 0.5. Answer will be just less than 20.5. Similarly, x equivalent to 5 power 73. Log x equivalent to 73 log 5. Log 5 is nothing but 1 minus log 2, which is nothing but 0.6990. In case if you got a doubt, log 5 is nothing but 1 minus log 2. Log 2 value is 0.3010, which is 0.6990. Whatever the answer that you get before dot, that is characteristic, add 1 to it. That is characteristic, add 1 to it. 73 into 0.7. 73 into 0.7 is nothing but 511 divided by 10, 51.1. I think the value should be just less than 51. You can check it out by multiplying the values. I hope it is clear. The question, please just don't multiply with one value, multiply the entire value. I hope it is clear. 73 into 0.7 will be 51.1. So just less than 0.7. It should be around 50 point something. You can do the value and you can check it out. This is one way of asking. Another way, they will also ask you, find the number of digits. Find the number of digits. Find the number of digits in 5 factorial into 2 power 12. Find the number of digits in 5 factorial into 2 power 12. Any factorial can be written as a power of prime basis. So 5 factorial, this can be written as either you can find the value or you can do it as 5 factorial. 5 factorial is 5 into 4 into 3 into 2 into 2 power 12. This is nothing but 4 into 2, 8. 2 cube into 3 power 1 into 5 power 1 into 2 power 12. This is nothing but 2 power 15 into 3 power 1 into 5 power 1. This is x. So log x is nothing but 15 log 2 plus log 3 plus log 5. I hope you are all there with me. So this is nothing but 15 into 0.3010. This is 0.4771. This is 0.6990. This is nothing but 4.5. 4 plus 1, 5. Here 5 digits. Here 1. here 1, 5 plus 1 plus 1, number of digits in these value, it is nothing but 7 digits. I hope you got the idea of finding out the number of digits. Suppose if we ask a bigger number, in case if we ask, find the number of digits, find the number of digits or an approximated value. What is the approximated value of 31 factorial? You might think that it becomes very complicated. For that, a famous professor has given an approximation, that is Stirling's approximation. These are not there in the syllabus, so I will not discuss. It is a root of 2 pi n into n by e power m. One beautiful proof is there. You can check it out if you are interested in mathematics, how to do the Stirling's approximation to find out the approximate value of 31 factorial. Once you get the value, automatically digits you will get it. This is the first key point of finding the number of digits. A power x equivalent to n, a power x equivalent to n can also be in decimal. So another important learning. Key point number 2. Key point number 2. Listen carefully, sir. Key point number 2. Suppose log 0.1 base 10 is there. 0.1 it is nothing but 10 power minus 1. So this value it is nothing but minus 1. Suppose if it is log 0.01 base 10 is there. These is nothing but 10 power minus 2 base 10. It is nothing but minus 2. Suppose if I take another value 0.001 base 10 is there. These is nothing but log 10 power minus 3 base 10. So these is nothing but minus 3. Suppose if I take, for example, if I take 0.0, if I take 0.0 some value, if I take 0.07, so the value should lie from 0.1 to 0.01, 0.1 to 0.01. So if I take, for example, 0.07, 0.1 plus 0.07, these is nothing but 0.107. So let me take, for example, some value. Let me take 1 minute, sir. Let me take a value which lies between these is nothing but, in case if you want a perfect value, what we'll do is, these is nothing but 10 power minus 1, which is nothing but 1 by 10. These is nothing but 10 power minus 2, which is nothing but 1 by 100. These 1% and it is 10%. 10% is going to 1%. Take any value. Suppose, for example, I took log 0.08, which is 8%. Can I say that this value lies from minus 1 to minus 2 or between minus 1 to minus 2? Am I right? Minus 1 to minus 2. Minus 1 to minus 2. Any value, it is nothing but minus 1 point something. Yes or no? So this can be written as minus 2 plus fractional value. Am I right? Minus 2 plus fractional value. Minus 1.2, it can be written as minus 2 plus 0.8. Minus 4.7, this can be written as minus 5 plus 0.3. Are you all with me? So these are nothing but a characteristic for this question, and these are nothing but a mantissa. Fractional value will always be positive. So minus 2 plus positive. Now minus 2 plus positive. I hope you are all there with me, right? So these are nothing but minus 2 plus positive. Next one, suppose if I take, for example, 1 minute, sir, log, if I take here any value, these are nothing but 10 power minus 3. It is 1 by 1000. 1 by 1000 is 0.01%. Am I right? No, 0.1%. 0.1%. 1 by 10 into 1 by 100. I hope these example it is clear, right? So 0.1 to if I add 0.02, 0.002 I will get 10 power minus 1, 1 by 10, it is nothing but 10 percentage, it is nothing but 1 percentage. 10 percentage going down to 1 percentage, so the value will be minus 1 to minus 2. So answer is, here also it will be minus 3 plus fractional value. Minus 3 plus fractional value. You can take any value which lies, which will be from minus 2 to minus 3. This value is greater than point, this value lies from 0.01 to 0.001. I hope it is clear. Any value from minus 2 to minus 3, it is written as minus 2 point something, minus 2 point something. Now what is important to me here is, what is important is a very important conclusion. In the exam it will be asked. So I will write it like this: 0.1 base 10, it is nothing but minus 1 log 0.01 base 10, it is nothing but minus 2 log 0.001 base 10, it is nothing but minus 3. Any value which lies between these two values, any value which lies, so answer will be between minus 2 to minus 3. Minus 2 to minus 3 is minus 2 point something, which is nothing but minus 3 plus something, some positive value. What is important here is, for example, see here sir, these, let me take a value, point, for example 007 is there, 0.01 to 0.001. This is nothing but characteristic. Now characteristic, what is the value? We got 3. If we got 3, after dot to first significant digit, after dot to first significant, how many zeros are there? 2 zeros are present. I will again come back to you. Take a value which lies between these two values. Answer lies between minus 1 to minus 2. Answer lies between minus 1 to minus 2. It is nothing but minus 1 point something. So here it is nothing but minus 2 plus something. Yes or no? Minus 1.2 is minus 2. If the characteristic is 2, if the characteristic is 2, here it is after dot to the first significant digit, there will be 1 0. These 0.1 to 0.07. These is nothing but 1 by 10, 10 percentage. These is nothing but 1 percentage. 7 percentage lies from 10 to 1 percentage. Very, very important point. See here, if the characteristic is alpha, number of zeros after decimal to the first significant digit, it is alpha minus 1. If the characteristic is alpha, number of digits after dot to the first significant, if it will be alpha minus 1. If these n value, it is in decimal, please write down that point. If n is in decimal, log n base a, it will be minus alpha plus fractional value. It will be minus alpha plus fractional value. I hope it is clear. Then the number of zeros, after decimal, very important point sir, after decimal to the first significant digit, it will be alpha minus 1. It will be alpha minus 1. If n is in decimal value, log n base a, if it is giving minus alpha plus fractional value, these is nothing but a characteristic, these is nothing but a mantissa. N could be greater than 1, n could lie from 0 to 1. Two cases are there. N could be a greater than 1, n could be from 0 to 1. Suppose for example 3 power minus 12 is there. 3 power minus 12 is there. He is asking two questions. Find the characteristic of 3 power minus 12 and find the number of zeros. Find the number of zeros after decimal to the first significant digit. First significant digit. Let us see these two questions. These are nothing but x equivalent to 3 power minus 12. So log x is nothing but minus 12 into 0.3010. These are nothing but minus 3.6 something. These are nothing but minus 4 plus fractional value. Characteristic is nothing but 4. Number of zeros after decimal to the first significant digit, it is nothing but 3. I hope the idea it is clear. Extremely important idea, sir. There are two cases that are possible. N will be greater than 1, n will be from 0 to 1. Sir, why we got two cases? Now once I explain you the exponential function, once I explain you the exponential function, then logarithmic function, you will understand why two cases will be there. Suppose if it is a power x equivalent to n. Suppose case 1 it is nothing but a greater than 1. Case 2 it is nothing but 0 less than a less than 1. A can be 2 here or a can be half here. Am I right? Any value greater than 1. So this case will be y equivalent to 2 power x, and this case will be y equivalent to 1 by 2 power x. Similarly, in a logarithmic function, if a power x equivalent to n, x equivalent to log n base a, again two cases will be there. Case number 1, a is greater than 1, and case number 2, a will be from 0 to 1. A will be from 0 to 1. I hope it is clear. This is also nothing but 1 by log a base n. 1 by log a base n. I hope the idea it is clear. That is the reason we took the two cases, where one case is lying from 0 to 1, another case is lying from a greater than 1. I hope the idea it is clear. What are the things that we discussed in today's class? We discussed logarithmic properties. Then we discussed what is a characteristic and mantissa. How to find out the number of digits by using characteristic, which is characteristic plus 1, number of digits. Then we have also seen the pattern where two cases are there. Log 10 base 10 it is 1, log 100 base 10 it is 2. So any value lies between 1 to 2. Between 1 to 2 is 1 point something. So here we got positive value. Next case what we took is log 0.1 base 10 it is minus 1, log 0.01 base 10 it is minus 2. So the value lies between minus 1 to minus 2, which is minus 1 point something, which is minus 2 plus fractional value. Characteristic is negative here, and here it is coming out to be positive. I hope you understood how to find out the number of digits. In case if you want to find the number of digits for n factorial, you can use Stirling's approximation. You can check in Wikipedia how this concept can be used to solve these approximately root of 2 pi n into n by e power n. This is an Stirling's approximation, not required. Generally it is required for MSc and high level mathematics. I hope the idea it is clear. If you learnt a few concepts through this video, kindly like the video, kindly share this video to all the students who are struggling with this topic, and don't forget to subscribe to our channel to get the new concepts uploaded notification. Thanks a lot once again, with love.